Okay, now we're ready to talk about radioactivity. And there are three different ways that a radioactive nucleus can decay. So what do we mean when we say that a nucleus is radioactive? It means essentially that it's unstable. And it could be unstable because it has too many protons. It could be unstable because it has too many neutrons. It could be unstable because it just has too much energy. So in order to get rid of that energy, it can do one of three things. It can emit a alpha particle, a beta particle, or a gamma particle. So let's explore each of these situations. So first of all, what is an alpha particle? So an alpha particle is going to be a helium nucleus. So a helium nucleus has 2 protons and 2 neutrons, so we would say it's a 2-4. So let's pretend that we've got aluminum 2813 here, and it's unstable. Okay, it's going to emit an alpha particle. So what does that do? So do you remember your nuclear chemistry? So remember that this thing here is like an equal sign. So that we've got, it's going to give off the alpha particle, so that 13 minus 2 is 11, and then 28 minus 4 is going to be 24. So notice that aluminum changed into sodium when it emitted the alpha particle. So in an alpha particle reaction, notice that the element changes. It changes from one element into another element. Now there's another way that a nucleus could become more stable, and that's by changing one of its neutrons into a proton, or changing a proton into a neutron. So we already covered that. That was called the what force? The weak nuclear force. So we're going to start with the same element. So here, this one here is going to be our unstable nucleus. But this time, instead of giving off an alpha particle, it's going to give off a beta particle. Now what's going to happen is one of the neutrons inside of this aluminum nucleus is going to turn into a proton, and in the process it will emit a beta particle, and it's also going to emit a neutrino, which we don't care about. Okay, so let's look at what happened to the numbers here. Do you see that this 28 changed into a 28? Well, that's not very exciting. So why did this number up here not change? Because after all, a neutron changed into a proton. So this one here has an extra proton. So it went from 13 to 14. It added a proton. So why didn't this thing go from 28 to 29? Because it's missing a neutron. So that when you add, so this one here, a certain number of neutrons plus a certain number, well, we can calculate it here. So it's going to be 13 protons plus, okay, now 28 minus 13 is 15 neutrons. And then what did it do? So over here, we're going to have 14 protons plus, but one of the neutrons disappeared. So it's going to add 14 neutrons. And 14 plus 14 makes 28. So there was no change in the mass number of the element. But the element did change. So it went from aluminum and it turned into silicon by emitting the beta particle there. And you could also have a beta plus situation in which you have too many protons. and then a proton could change into a neutron. But that's not illustrated here. Now, then you have your third situation where it emits a gamma particle. So you've heard of the word gamma, remember? Gamma radiation. So on the electromagnetic spectrum, you have radio waves, and then infrared and visible and ultraviolet and X-rays and gamma rays. So in this case, you start with aluminum and you end with aluminum. All that happened was that the aluminum gave off some light in the form of gamma radiation. And so it's like, here is a pen, and if I drop it, it's still a pen when it hits the table. The only thing that happened was it gave off some energy into the environment. And so the energy is very, very high energy. So it has a high frequency, and so it's going to be the gamma rays, which we're going to find out are very dangerous. So you don't want to be irradiated by gamma rays unless, of course, you're the Incredible Hulk. All right, so there is the 3 different ways. So if you're one of my students, make sure and know what an alpha particle is, know what a beta particle is, and then know what a gamma particle is. I'm not going to have you do this nuclear chemistry thing on the exam. Okay, let's take a break, and when we come back, we're going to talk about a decay series.